Yeah, so hello everyone. My name is Minko Gechev. I'm working as an engineer at the Angular team at Google. Today in this presentation, I would want us to go pretty much in depth and in breadth the implementation of the Angular CLI. So a few words about me. I'm committing pretty frequently on GitHub. In fact, I recently realized that you can judge about different events in my life based on this contribution streak. Here in August, for example, we started testing Ivy with third-party libraries. In November, I started building an exciting tool, and you can see even my vacation days with lighter green colors. So I developed a few tools like Gechev, tool for predictive prefetching for JavaScript, which combines some things that I'm excited about, as you're going to see, compilers, and also data analytics. Developed Revive, which is a tool for Go, linter, and Colorizer that is now running as part of the Angular CLI. So in this talk, we're going to go pretty much all the way into the internals of the Angular CLI. You really don't need to understand any of these things in order to use the CLI, but you would get a really good understanding of how things work internally so that you can get inspired to build your own CLI tool on top of the CLI or start contributing to Angular. Since I know that this is not an Angular-specific conference, I would want to just make a very brief overview on what the Angular platform provides for everyone. So we have a framework. This framework provides different primitives for developing components, for dependency injection, and so on and so forth. On top of that, we have the Angular CLI and components for pre-built components such as material and the CDK. The CLI is developed by the Angular tooling team, and we have also, obviously, the Angular components team. On top of that, we also provide a way to implement internationalization in your application at compile time. So we have a specific compile time step that allows you to build zero overhead internationalization. We have a language service, router, animations, and so on and so forth. So we're providing this entire platform. Today, we're going to focus only on the CLI, although we're going to mention a couple of things from other modules as well, including framework, in particular, how we're compiling your applications to make them efficient. So by the end of the talk, you would know exactly what is happening in this example when creating a new application first, scaffolding it, installing different packages. Right after that, let's say, adding an Angular universal support for this application. We're going to see how ng-at in fact works, how it is transforming your project. Right after that, we're going to discuss how you can add another package, for example, Angular Fire, and what is happening internally, how we're recognizing that this application is an Angular universal app by in-memory traversing your directory and file structure of your projects. And finally, we're also going to discuss the build process, which is going to be triggered in this particular example by running the command ng-deploy. We're going to look at all the different compile time optimizations that we will be doing. For example, we'll talk about ngCC a little bit. We're going to discuss the ahead of time compilation of Angular, different tree shaking. We're going to look at Webpack and how it works, and so on and so forth. Right, again, one more disclaimer. You don't really need to understand any of the following content if you want to just use the Angular CLI. But this talk is going to provide you a good overview of the entire CLI architecture and also a little bit about compilers as well, because they're very heavily embedded in the Angular tooling. So again, we're going to look at the CLI. The CLI consists of the Angular CLI package. This is what you're supposed to install when you start developing with Angular. On top of the CLI package, we have Angular builders and schematics. The builders are a way for yourself to develop new commands for the Angular CLI. In fact, we have developed our own builders, our own functionality on top of the CLI pretty much the same way. We just implemented different builders, which are implementing the individual commands, such as ng-serve, ng-build, and so on and so forth. Schematics is a way for you to transform the files in your project structure, in your workspace. On top of that, we have jobs that are pretty much like standard processes. They're very heavily inspired by the Unix processes. We have different footprints for schematics. We have ng-add, ng-update, and so on and so forth. On the builder side, we're heavily using Webpack, although everything is absolutely abstracted. So we don't we're not going to break your project if we decide to switch from Webpack to something else, let's say rollup. We have TypeScript and Cursor, and finally on top we have NGC, which is the Angular compiler. Now let us start first discussing the right part of this diagram. We're going to look at the foundations of the Angular CLI, in particular how we're bootstrapping a project. You can create a new project by running the ng new, the name of your project, and specifying a particular collection. What the CLI is going to do in this particular case is first read the schematics, read this collection from the disk. It is going to create this in-memory file system of your entire project. So we're particularly choosing to make it in memory so that you can do a variety of different transformations on top of this file structure without us touching anything on your machine, without corrupting the current project structure that you have. Imagine that you perform a series of different transformations on top of these files. You create new files, you modify the content of existing files, and if any of these operations fail and it leaves your project in an inconsistent state, we would not want to touch your file system and corrupt it as well. We would want to discard all the changes. This is pretty much similar to the database transactions, if you're familiar with them. We're performing one in-memory transaction, and if it is successful, we're committing the transformation. We're committing the transformed files to the disk. Another reason why we decided to go in particular with in-memory transformations instead of touching directly your files on the disk is because of this memory hierarchy. So if you have studied computer architectures in college, in university, or if you're familiar with this memory hierarchy from literature that you have read, you probably know that there are different types of memory which you can access, and you need to pay different cost. For example, if you're touching your solid state memory, your SSD disk, this is going to be quite expensive, much more expensive than directly touching the L1 cache of your CPU. Somewhere in the middle is the random access memory, or the RAM, where we're performing the different transformations with schematics. This is still very expensive. It is hundreds of times more expensive than directly touching memory on the cache, because the cache is just like solid state memory again, which is directly attached to the chip of the CPU. So it couldn't be, there is no way for it to be as fast as the RAM memory. But still, it is much, much cheaper compared to directly reading files from the disk. Now, there are different advantages and disadvantages of this as well. For example, if we're performing operation on different arrays in this particular case, we're going to be able to take advantage of also cache locality. So the individual elements from the array, all the neighbors around the element that we're currently traversing, they're going to be already located in the cache. So we'll be able to take further advantage of further speed boost because of this as well. So when I'm talking about this memory hierarchy, I'm very frequently reminded of my alma mater, I'll say, the college where I studied software engineering, computer science. This is the faculty for mathematics and informatics, or to Sofia University. My guess is because, well, we had Russian culture very heavily embedded in Bulgaria. My guess is that in college I had really, really similar experience to probably what you did. It was a very interesting institution where we studied a lot of math. It was, I wouldn't say that I'm currently applying most of my math knowledge in my software engineering practice today, although I really find valuable what I studied at college. But on top of the math, there was also there were a lot of parties. And my guess is that they were with similar intensity to what you have experienced. Here is an authentic photo from one of the parties where we were everyone was pretty much enjoying it. I was thinking about the test next day. So anyway, when we're talking about schematics, we are usually using them for scaffolding new projects. We're using them for updating existing projects and also updating them when you would want to add new functionality to your entire workspace. So we have also code transformations, which is something in common with all of these. With scaffolding, we're performing these code transformations once we're reading the schematic collection from the disk and right after that committing it. So in the meantime, we're performing some code transformation in order to just populate the existing schematics with data for your project. We also have updates that are part of ng update, for example, where we're updating existing projects to the latest version of Angular. And when we are adding a new package, for example, if we want to add Firebase support, we'll be performing some transformation as well, which involves creation of different configuration files, as well as transformation of your source code files, so that we can add particular piece of the Firebase configuration directly to your project. We're going to focus now a little bit on code transformation. We're going to discuss different ways we can implement this code transformation and their pros and cons. So obviously we can directly apply string replacements, right? We can just take the string, because the content of each individual file is nothing more than just a string. We can take the content of the string and replace the particular markers that you would want to populate with particular values. We also have regular expressions, which are really powerful. Regular expressions are great for performing different transformations in regular languages. And we have also AST transformations. So we're going to reach out to AST transformations, and I'm going to tell you how exactly we're using them in the CLI. But first, here is an example. So as part of the CLI and schematics, we have this template language. Here, you can see that we have a component that has a selector that we can replace with a particular value, because this is just something like a template that we would want to transform and eventually save onto the disk. Of course, we can apply a very simple transformation, and this may work for this particular scenario. Now we can store the modified file on the disk, and that's perfect. With regular expressions, we can make it a little bit more dynamic. For example, we can capture the name of the placeholder here, which is selector, and we can take the selector name from a pre-populated data object and directly replace it and have the final result app component. And this is working fine. However, there are some more complicated cases. Here you can see that one of the transformations that we had to perform as part of the migration to Ivy was to find all different view child property selectors in your components and add this static property. Now, what kind of transformation, code transformations can we apply here? Can we directly use a regular expression, or can we use a simple string replace? Well, this is going to be a little bit more complicated because we have three very important requirements. First, we should apply this transformation only to property decorators. If the decorator is used on top of a function or a method or a class, well, this is not going to work. We can potentially break already existing user code. The class also should be a component, so we cannot apply this transformation on top of an arbitrary class, which uses a user-defined viewChild decorator. And further, this should be also a symbol coming from Angular. We should verify that viewChild is something that comes from Angular, not from a user-defined decorator at the end. This means that we can eventually use some kind of a hyper-complicated regular expression, which is definitely not going to work in the general case, since, well, it is just not flexible enough. And in contrast, TypeScript is not a regular language itself, which could be simply parsed with a regular expression. This means that in order to apply a proper source code transformation, we need to use the source code plus grammar. And the grammar is the interesting thing that I would want to focus on here. The grammar is pretty much the thing that describes all the syntactically correct programs, all of them, in your programming language. I'm saying only syntactically correct programs because we also have semantic checking in some programming languages, such as TypeScript, for example, where when passing the semantic checking, we can invalidate some of the programs in the language because of invalid type annotations. When we start now talking about grammar, this means that we are one step closer to start talking about compilers. And I really like talking about compilers. This is another thing that occurred to myself when I was at college, where we had a data structures class. We had, that was my first or second year in college. I didn't believe that mortals can create compilers back then. That was something super exciting for me. Imagine having your own programming language. And our teaching assistant said that we will be able to implement one tiny interpreter during our next data structures exercise. I was really excited. I arrived there 1 hour earlier, and well, the teaching assistant didn't arrive, and he was missing by the end of the semester. So I put all my skills together back then, and I implemented a tiny programming language in Java. And since then, I've been writing a lot about programming languages because there were not too many resources on how you can implement your own language. So there was an article that I wrote about developing a statically typed language with JavaScript, something like a lambda calculus, which has types. Later on, I saw that this was maybe a little bit too heavy with all the mathematical foundation. So I wrote a tiny article on how we can implement the compiler on 25 lines of JavaScript. Well, this received more attention, but at the same time, I want to make it even simpler. So almost the last thing that I did was to record a podcast on how we can implement compilers. And finally, to make it even more accessible, I implemented the compiler from Angular application to a virtual garden of trees, where you can pretty much walk around your components and your modules, and you can explore your application in the 3D world. That was around Christmas time, so that's why we have different Christmas trees. That was a very interesting experiment. Maybe not, I wouldn't say the most useful one. Probably that's not how you would want to make code reviews, walking in this virtual reality, but well, that was, this excited a few people about compilers. So today, I'm going to talk about compilers as well to you a little bit in about 2 minutes to make sure that we're understanding all the different operations that the CLI performs. Again, you really don't need to understand compilers to use the Angular CLI or Angular in general. So a compiler is just something that receives some input and produces an output. In the case of TypeScript, this input is nothing more than just a TypeScript program, and the output is just a bunch of different JS and DTS files. The compiler has a front end and a back end, just like a web system, but they have quite different responsibilities. The front end is responsible for performing lexical analysis and syntax analysis. The lexical analysis is also known as like tokenization, or the lexical analysis is also known as a lexer. And the syntax analysis, well, that's the actual parsing that is happening. So if we take this tiny program, our const product equals a multiplied by b, and we tokenize it, we're going to get the list of tokens. These are just different objects. Usually these tokens, they have a lexeme, which is the substring of the program that they represent. They have also a type. In this case, const is a keyword, and product is an identifier. They usually also have a position in the program so that you can get more accurate compile time errors. You can get the exact line and location, line and column where a particular error happened. From what I know, like in Fortran before, you didn't have really such sophisticated syntax analysis, so you're just getting an error. You have error in your program, right? So that's not the ideal error message that you would want to get. Now, once you get your tokens from your program, you're getting to the next stage, which is the actual syntax analysis. Here you're passing this list of tokens. It could be a stream of tokens, actually, in the general case, for incremental parsing, together with the grammar of the language to the module for syntax analysis. Based on the grammar, the parser is producing a tree, which is called an abstract syntax tree, or an AST. Respectively, for more complicated programs, this AST is going to be more complicated as well. Now, let us go back to the previous requirements of our code transformation that we would want to perform on top of all the different viewchild decorators in our Angular application. Remember, we want them to be property decorators, and also we want the class associated with these properties to be a component, to be the controller of a actual component. So what we can do here is just implement the AST visitor pattern. Thanks to the grammar of the language, we're going to get the proper nesting in the AST, so that with the visitor pattern, we will be able to traverse the AST in the right order, and we will guarantee this nesting. Notice here, for example, we're traversing all the different properties of a class. So we're getting already the requirement that we were looking for, property decorator. Also, we would want the class to be, in fact, a component. So we're verifying when we're visiting a particular class decorator whether it has a decorator of type component, and if it does, we're visiting the component itself. So we're guaranteeing that this transformation is going to be correct just by taking in mind the grammar of the language. However, we still don't have a guarantee that the viewchild decorator comes from Angular. So what we could do here is just use the TypeScript type checker. The type checker is a very simple abstraction that comes from TypeScript, which is performing different type arithmetics on top of your program. Getting it from the program itself, and we can get the type at a location. So we can get the type of the viewchild AST node, and we can verify whether it comes from Angular or not. This is in fact how we're performing all the different transformations in Angular. That is how we're performing ng-update, the command for moving you to the latest Angular version. The focus in version 10, though, is to make Angular CLI even stricter, and also to increase visibility in the community. So the visibility increase in community, this is something that we can talk about, like in the Q&A session, for example. This is mostly related to involving the community more in the Angular development process and also community management process. But today we're going to focus particularly on the more technical part of it, the opt-in strict mode. In general, with a strict mode in Angular, we're aiming to enable stricter type checking also in Angular templates. We would want to disable ES5 and CommonJS support by default. So you would have to opt into that, and to reduce side effects so that we can enable more efficient code optimizations. We're going to focus on a couple of these things. But in general, your general idea for our opt-in strict mode should be that you will be getting more type errors, which is actually a good thing. There is a great paper by different folks from Microsoft and from the academia which prove that by using TypeScript type system with strict type checking, you're eliminating 15% of your bugs ahead of time, just when building your application or while developing it. Because the TypeScript type system, including Flow actually in this paper, they're going to catch these errors much sooner before you deploy your application to production. Strictness also allows us to do a few other fancy things. For example, we have automated updates with much more higher level of accuracy. Now, I hope now you understand why ng-update with more type information is more valuable. Because sometimes in ng-update, when we want to migrate your application across two different or more Angular versions, we're using type information. And if you cast something to any, for example, or if you have implicit any in different cases, this means that we cannot take advantage of the type checker in a powerful manner. So we wouldn't be able to extract type information for your symbols, and from there, we wouldn't be able to reason good enough about your program. Strictness helps to a huge extent with compile time optimizations as well, because we can perform much more accurate code transformations and tree shaking by knowing such things. All right, now let us discuss the development-facing APIs of these three different features of the Angular CLI. So first, let us focus on the scaffolding and the ng-add API. So if you're a developer, everything you need to do in order to add ng-add schematics or ng-new schematics to a particular Angular package, not particularly Angular actually, schematics is widely used across different communities as well, even Nest.js and React. So if you have your package JSON, you just need to reference your schematics collection inside of it. Inside of your collection, you need to specify a factory, which is just implementing the code transformation, and also a schema, because we're performing type checking again. Since this is JSON, we're collecting this type information at runtime and verifying whether the arguments that you have passed to your schematic align with the requirements that you have declared in the schema. This is the factory. The factory is just a simple JavaScript function that accepts a tree, which tree is nothing more than just this in-memory file system that you can transform and right after that return so that we can commit it on the disk. Now, finally, updates. So with updates, we're performing something quite similar. You're still referencing your migrations as part of your package JSON. And in your migrations.json, all you need to do is just declare the individual migrations in this JSON object. You need to declare their factories and also the version so that we can run them in the appropriate order. We're applying version. And finally, what I wanted to recap this first portion of the presentation is that schematics are in general used for code transformation. They're heavily using parsing and like in general lexical and syntax analysis in order to perform context-aware replacements, taking advantage the language grammar and type system. All right, so that was the first part of the talk. The second part is going to be about build time optimizations in Angular. We're going to look at some of the build time optimizations that we're doing on the Angular sites and also describe different optimizations that we're doing thanks to tools built by communities such as Webpack, Cursor, and others. So this is going to be this portion of the Angular CLI's architectural diagram, where we're going to talk about builders, we're going to talk about jobs, Webpack, and so on. Now let's start talking about builders first. Let us see what is the life cycle of an Angular CLI command. So first, you have your Angular CLI and you're typing ng and the name of your command. For example, if ng build, we're going to translate this ng build to ng run, the name of your default Angular CLI application, :build. We're going to look at angular.json after that in order to find a specific implementation of this command, which is going to be pointed there, and we're going to require it from the disk. Right now, since we have the actual builder that implements this command, we're just going to execute the command, and that's it. Here are a couple of examples. As I mentioned, ng-serve is just a shortcut for ng-run, the name of the default application in your project, :serve, and ng-build is pretty much the same for the name of your default application, :build. The interesting thing here is happening in the build command. This is probably the most advanced command right there, on which we have iterated quite a lot recently. So there we have the browser builder. The browser builder is something that takes your development build and optimizes it to a big extent. So this here is the Angular CLI building Angular IO. You can see that we're optimizing the bundle with like about 10x. So although given that there are a lot of comments and a lot of white space in the development bundle, this doesn't sound like far too impressive, but you're going to have a lot of interesting things happening under the hood in terms of tree shaking and dead-code-elimination. So here is our build pipeline. First, we're compiling the application with ngc. is the Angular compiler. Right after that, we're passing this output to the TypeScript compiler. After that, passing it to our build optimizer. Next, going to Webpack. After that, going to Cursor, which is the JavaScript optimizer that we're using. And finally, we're again going to the TypeScript compiler in order to downlevel JavaScript. I have missed a few phases here. For example, I have missed the Angular compatibility compiler, which translates Vue engine applications to Ivy. And I have also missed our internationalization replacements, as well as our internationalization extraction. I really think that we have a very efficient way to implement serialization. Unfortunately, that's a little bit out of the scope of this presentation, but we'll be following up with a blog post on the topic. Now, let us start by describing Webpack. So Webpack, I'm sure that you already know what that tool is. It does bundling. There are a few interesting things to notice about this bundling, though. In general, we all know what bundling is. In general, we just have an entry point, and we are finding all this like transitive closure of this entry point, which includes all the static imports, and we bundle everything together into a single JavaScript file. This is clear and quite obvious. The interesting thing is how Webpack is doing this, because this opens a lot of doors for optimization. So here, for example, we can see that the index.js file depends on the utils file. What Webpack is going to do is merge these two modules in the same namespace. Notice here, we have a subtract function declared in utils.js, and we also have one declared in index.js. Since we are merging everything into the exact same namespace, Webpack first have to rename the index subtract function to index subtract so that we don't have namespace collision. It is really important that we are merging everything into the same namespace, because this opens the door for a lot of dead code elimination. Notice also that at this point here, Webpack, it's introduced all these different symbols in the same namespace, although we are not using some of them. For example, in this entire program, we're using only the add function. We're not using subtract or index subtract, but still they're part of the final bundle. So no tree shaking has been applied to this point. Now, when we go to Cursor, though, Cursor is going to apply some more advanced dead code elimination and tree shaking. So Cursor is just a ES 2015 version of Uglify.js, and it does some pretty interesting optimizations under the hood. So here is what dead code elimination techniques Cursor is going to apply to the Webpack bundle that we just looked at. Notice there are a few interesting things. First, it is getting rid of all the different unused functions. So we no longer have our subtract function, neither our index subtract, because we're just not using them in our program. See how the actual tree shaking is applied by our code optimizer, Cursor, not by Webpack or Angular. Next, we have only the add function available right here. But the interesting thing is that Cursor was smart enough to evaluate ahead of time this add function. First, it replaces the add function with its body on the first pass, and right after that, it performs this partial evaluation in order to produce the final result, which is just console walk3. This is quite impressive because of two different reasons. So how Cursor is going to implement this is first build an abstract representation of our program, which is going to be something like an AST, but a little bit more focused on performing just different passes on top of it, just different traversals on top of the AST, and performing different code transformations so that we can produce the final result, which in this case is console.log. It does several such passes or traversals, when on every next pass, it is able to optimize more. And finally, it reaches the final optimization point when it just logs 3 in the console. Another interesting thing is purity. So notice here, in this snippet on the left, we have get data, which just goes to local storage, which just gets an item from there and returns it. If we optimize this with Cursor, out of the box, we're just going to get local storage get. And that's fine. This is absolutely fine. However, it's fine because in this case, Cursor has just taken the body of the function and replaced the function invocation with it. However, at the same time, local storage doesn't perform any side effects. So if it doesn't perform any side effect, our program is going to be completely blank, like it doesn't do absolutely anything, right? In order to annotate our program in a such way to notify that we don't perform any side effects, all we need to do is just put this command pure in front of the method invocation. And in this case, we're not going to generate anything. So just keep this in mind, because this is something that we're using in the Angular CLI to optimize the output further. Before going there, though, I would want to talk just a little bit about NGC. NGC is the Angular compiler, which takes your Angular components and compiles them to a very efficient version of themselves. In Angular, we have been doing compilation for since pretty much the beginning. So we had this concept of ahead of time compilation where we're compiling your templates to very efficient JavaScript instructions. Here, for example, we're taking your Angular component and compiling it to a component.js file and a DTS file. In the DTS file, we're encoding a lot of different metadata hints for the further compilation. For example, in the component.dts file, you can find what is the selector of this component, whether you have any vQueries, and so on and so forth. Magnifying further, for example, this compiler is going to be transformed to something like this. Notice that there are a few interesting things. So first, here on the left, we have our ngIf directive, which is, it exists in a string. So this string is not something that Cursor understands and can optimize. However, on the right side, we're turning this into JavaScript instructions. So we're going to have a direct import from Angular command to ngIf. And we're going to add this ngIf directive in the list of directives that is used in the component. Later on in this template function here that you can see, we would have specific invocation of the ngIf directive where it makes sense. So this opens the door for a lot of optimizations. Here we can apply directly dead-code-elimination, because once Webpack bundles everything and puts it into the same namespace, Cursor can look at all the symbols that we haven't imported, that we're not using in our template functions, and it can directly get rid of them. This is how tree shaking in Angular CLI works. It is in combination with the Angular CLI, with NGC, and Webpack and Cursor. There are a lot of interesting things in the Angular compiler as well, though. Maybe it's worth it to do another separate talk on this topic. One more optimization that we're doing now in Ivy compared to Vue Engine before is this compact instruction generation. So in Ivy, our templates are from like 10 to even 50% smaller compared to what they were in Vue Engine, only because we're no longer generating ng factories. This is probably, if you're not doing Angular, this is not going to mean too much to you, but in general, think about it as, well, we are now generating less source code. That's why we're more efficient. Now, let us finally talk about the Vue optimizer, the build optimizer. The build optimizer is something that we maintain. It's pretty much processes your Angular application after we have compiled it to TypeScript. So here is an example what the Vue optimizer is going to do. So first, if we have our class, which has a specific property, and we minify this with Cursor, we're going to get something like the output below. However, notice that this class doesn't perform any side effects again. So we can annotate it with the pure annotation, and Cursor is not going to generate anything. This is something that we do in the Angular CLI. So for each one of your components, we're going to assume that it does not have any side effects, so that Cursor can get rid of it by using the specific pure annotation. And this is another tiny compiler, because it just parses your source code by using the TypeScript parser, and right after that, we generate this extra annotated source code. Finally, let us talk a little bit about how we are using TypeScript yet again. In fact, in this stage right here, we will be generating ECMAScript 2015 bundles for you. However, for some older legacy browsers, we would want to support ES5 as well. So here is where differential loading comes into play. With differential loading, we would want to produce two different views of your application. One for legacy browsers and one for modern browsers. Legacy browsers, they can only use ES5, so they don't understand modern syntax of ES 2015, and they also need some extra polyfills. However, developers who have modern browsers, well, they don't need to pay the cost for this extra JavaScript, which is also slower to execute. That is why we are using differential loading and reducing the bundle size for modern browsers even further. With differential loading, the user is going to load the HTML of your application. From there, it is going to find two different script tags, one for modern browsers and one for legacy browsers, and it is going to respectively download the one that corresponds to the feature set that the browser supports. Here is how this works. It's pretty simple in the end. We just have the two different script tags. We have script type module for the modern bundle and script with no module attribute for the ES5 version. So here we're using TypeScript in order to down level your JavaScript ES 2015 bundles to ES5. Now let's put this all together and recap the entire presentation. We have a couple of compilers that we're using. So NGC is the Angular compiler, which performs this ahead of time computation to optimize your templates and also to generate very efficient JavaScript instructions for their rendering. We have Webpack that is performing this bundling, but does not necessarily perform tree shaking in this case. By reducing side effects, with the strict mode coming up as an opt-in flag in Angular CLI version 10, we will be able to perform some extra Webpack tree shaking, but not at this point. The build optimizer is something that annotates your symbols as side effect free, and we're able to perform more efficient dead-code elimination. Cursor, on the other side, it performs its dead-code elimination. And on top of that, once we have our ES 2015 bundles on which Cursor operates, we're down-leveling them to ES5 so that your legacy browsers can take advantage of them with differential loading. Now, just a few tips on how you can debug your build. In order to understand the individual steps better, you can you can just provide this ng build profiling equal true when you're running ng build, and you're going to see a profile output that you can directly load in Chrome DevTools and see the individual steps of the build process and how long they took. This is only possible because our build process is entirely in JavaScript as well. Further, you can debug your bundles and see what didn't get tree shaken well enough by using Source Map Expert. And you can also look at the JavaScript coverage tab in Chrome DevTools. Now, the developer-facing API of everything that we talked about so far in order to optimize your application is just ng-build --prot. That was pretty much everything. I hope that we were able to look behind the scene of this machinery behind the Angular CLI. We were able to explore all the different pieces to a pretty decent level of detail so that we can give you a good idea on how everything works under the hood. That was everything. And thank you very much for your attention. If you have some feedback, please leave it at mgv.io/talk. I would love to answer your questions.
Yeah, thank you, Minko.
Sure, yeah.
Talking about compilers. And looks like we have a question regarding Angular CLI from Andrew. And Andrew asked us about what was the reason for refusing the command for generate custom webpack config in Angular version 7. Now, because of this, you have to use a special plugin to merge configurations, and it has its own limitations. And looks like he reached of limitations.
Yeah, that's an excellent question. So there is a really excellent talk by one of my former coworkers, Radu Kirov, Power in Constraints. So when we set some further limitations on top of what is possible to do in Angular CLI, what custom plugins you can introduce, and so on and so forth, we open a lot of doors for more optimizations. For example, if you have a custom Webpack plugin that takes a lot of computational cycles in order to perform some operations of your application, this is something that is outside of our control, so we cannot optimize it further. Another problem of such approach could be that this plugin can destroy some of the assumptions that we have on your application. For example, if this plugin down levels scripts to ES5, there is no way for our build optimizer to perform quality transformations on top of your source code and annotate it with the pure annotation so that we can efficiently treat. Now, if we allow this to happen, this means that a lot of folks who have good understanding of the internals of the Angular CLI will be able to have efficient builds at the end. But others who are not necessarily familiar with the internals can shoot themselves in the foot, and, well, there is nothing we can do about them to support them. And probably the biggest reason why we decided not to go in this direction, actually there are two more. One of them is that we're able to transparently change things in the CLI without developers having to care about it. For example, something that we introduced recently is bundling with rollup first, and right after that delegating it to Webpack. So we introduced a rollup plugin in Webpack in order to enable more efficient tree shaking. If someone is able to plug into the pipeline of the CLI, we don't have the guarantee that these transformations will be efficient. And finally, automated migrations. If you have custom Webpack configuration and we decide that we need to take advantage of Webpack 5 because it is ready to go now, there is no way for us to migrate your custom Webpack configuration to Webpack 5. NGX Build Plus would still not let us do that properly because you may still have legacy plugins, but at least this is not something that we're officially, we are recommending as a workaround, but not officially maintaining. So you're using it on your own responsibility. And ideally, we don't want developers to diverge from the evergreen Angular CLI, where we'll be able to constantly push new improvements and make your bundle smaller and more efficient. That's our goal, just to enable ng update for everyone and make sure that everyone is always on the last version of the CLI. And yeah, the fewer custom things you have, the more efficiently we can do that.
Oh, pretty clear. Thank you for this answer. Another Andrew asked us about, could you please name your favorite Angular CLI features which are in development right now?
There are a few things that I'm really excited about. They're tooling related, not necessarily Angular CLI related, that I cannot name just yet. I'll be able to do that hopefully in a few months. Something that we're experimenting with quite a few things, but something that we're looking at right now is to enable Google Closure Compiler, which is something that we have been using internally. For example, Google Search uses Google Closure Compiler for very advanced optimizations. There is also really active research going on, not only inside of Google, across different organizations, on how to use type information to perform more efficient minification. This is something really exciting. And it is even harder to do with structured type systems such as TypeScript. It is much easier to do with type systems like Java's, where you have certain more guarantees. These are some things that are most interesting for me from theoretical and research perspective. So I'm curious what you're excited about.
Looks like we're excited about new optimizations of Angular, and I was wondering that time to time Angular becomes faster and builds became smaller. Can you predict the limits of optimizations for Angular bundle, for example? You know these numbers or not?
Yeah, well, in general, the smallest possible Angular could be is if you look at if you open Angular CLI, Angular.io, for example, you're going to see that we have quite some unused code right there. And the reason for this is because we still have some way to go until we perform the best possible lazy loading and until we perform the best possible tree shaking. However, if we're able to do that, ideally, we are able to completely stream the entire application. We'll be able to deliver only the green part of the JavaScript coverage that you're seeing in DevTools. So this would be somewhere around the limits. Probably we'll be able to get a little bit smaller with more efficient source code optimizations, in particular minification, but it will be somewhere around that.
You meant Google Closure Compiler, and when I seen your talk, I see that Tensor looks like a good son of Google Closure Compiler. Looks like it uses internally.
Yeah, we're using Google Closure Compiler internally, only Google Closure Compiler. It is really powerful, but it has its pros and cons. So problem with Tensor, let's start with the problems of Tensor, and after that I'm going to go to the problems of Google Closure Compiler. Tensor is really powerful as well. However, it consumes a lot of memory, and very often we're getting out of memory errors for Angular CLI developers because Tensor has been consuming far too much memory on their machines. Another problem is that although it is fast, it is still implemented in JavaScript, so it cannot be as fast as something that is written even in Java. And another thing is that Tensor is something which is developed. This has pros and cons as well. Like everything has trade-offs in software engineering. That's how I feel. It is developed by the open source community, so it needs to serve everyone. With Closure Compiler, we're working on the same floor, actually, in Sunnyvale. So we can talk to them very frequently and work on different further optimizations. Closure Compiler, we haven't switched to this yet. First of all, because it's not written in JavaScript, so it's harder to debug, especially for folks who are not that fluent in Java, let's say. Further, sometimes it performs really aggressive optimizations, and you need to write your JavaScript in a specific way so that Closure Compiler can optimize it. And this can get really tricky at certain points, because if you don't follow these strict guidelines, Closure Compiler can try to optimize your source code, but it is also going to break it, and you're going to get some like super weird runtime error that you have no idea how to debug. Because of these developer ergonomic solutions, like concerns, we haven't moved to Closure Compiler yet.
Yeah, Google Closure Compiler looks too old in difference with another web technologies. And 1 year ago, last year HolyJS, we have a great talk about tricky optimizations with Google Closure Compiler and a big TypeScript project, how to deal with it. And looks like it's not so typical web development with to make aggressive optimizations using it. And nice to listen that you make a Tensor that can compile something like a Google Closure Compiler, and it's something new because Google Closure Compiler takes a very long life in development. I was really wondering about it. I want to ask you about a bit about schematics. So, is it Looks like it's a powerful thing for refactorings of big projects to migrate it for newer versions of Angular, and maybe to migrate some bunch of components and services. And I was interested about it can help legacy projects. Let's get a very ugly case. Big Angular projects with custom ejected Webpack config and that wants to migrate to Ivy render. Is it possible to use schematics or not?
Yeah, well, schematics just provides the what schematics is going to do is provide some API for you to read the entire project in memory, and from there on, it is on the developer to transform the project structure again in memory, and schematics right after that is going to compile it on disk. So it very highly depends on what custom things in Webpack you're using. If you're using some magic comments and there is way for them to be migrated, like because there are some constructs which are simply not deterministic, so there is no way for you to perform an automated migration, then you would not be able to. It completely depends on your custom Webpack config. Yeah, no. That's the most accurate answer I could give at this point without seeing the source code and thinking about it.
Yeah, I asked this question because of our Angular meetups in Russia. Sometimes we have talks about long story of refactoring of very old project based on Angular 2nd, Angular 3rd, and so on. So interesting to listen to hear about stricter templates of Angular, and I was reading a bit about it, and I was wondering that you need any keyword from TypeScript. How to avoid any keyword in Angular templates in normal development? Because for me, a good TypeScript project is a TypeScript project without any.
Yeah. With strict type checking, we have this would be enough. Actually, we have one more even stricter type checking. Let me see how it was exactly named. Full template type checking, I believe. If you use, so yeah, we have 3 different levels of type checking. The one that is on by default right now, which doesn't provide very, very strict features, but at the same time, it doesn't scare developers getting started with Angular. We have, here it is. I'm looking at the config options now. We have strict template type checking, the thing that we would want to enable, where we are still not going to be able to type check everything absolutely correctly, but at the same time, the TypeScript type check, our type checker is not going to throw some annoying errors. For example, imagine you have a input which accepts a Boolean property. If you would want to pass the Boolean literal true, it might get really confusing for our compiler whether this is the Boolean true or the string literal true, for example. This is something that you should the strictest full template type checking, I believe, is going to throw. So you can use full template type checking. This could be if you're willing to take the pain of it. This is going to be the way to go.
Okay, and is it Ivy render really production ready now for current version? Can we use it in production without fear of bugs?
Yeah, you can use the renderer. Already about 40% of public Angular applications that we're tracking are using Ivy. And in Google, a lot of projects are building with Ivy currently. My Google Assistant decided that I'm talking to it. And we'll be flipping the flag for everyone, hopefully by the end of this year at Google. But it's completely production ready, and we're constantly improving it.
Yeah, really good to hear it, because we are waiting of EV render for maybe a couple of years, and it was postponed for a couple of times, for a couple of released, because of it's not ready. It was not ready, but now it's ready, and it looks. It's heard really exciting about our optimization for our applications.
Yeah, we want to make sure that it's backward compatible. That's why we postponed it for a little bit.
Sometimes I was interested in Angular, not for rendering of HTML, for rendering different things like console applications, WebGL applications, and so on. And I used rendering factory second for this. Do you have plans to do something for Ivy render? To make your own render, not for HTML.
Yeah, that's something that. So just to correct myself, because I mentioned to enable full template type checking. The name of the flag is actually strict template. So if you want the strictest possible behavior, you should look at strict templates. So the rendering is actually independent from the template language. So in general, with Ivy, if you would want to use another template language, if you prefer to use lit HTML, or if you want to use JSX, this is something that you can implement yourself pretty much. We don't want to do that in Angular itself. We don't want to do that as an official recommendation from the team, because we in general believe that Angular projects should be consistent, and we would want us to have only a single way of implementing components. This is something that we really believe in, and we think that it brings a lot of value to a lot of organizations. So although you can use JSX if you implement your own JSX templates for Angular, that's absolutely fine. I would even encourage someone from community to give it a try. A lot of interesting experiments coming from the Russian community, and it will be super exciting to see someone implementing JSX for Angular. Although this is possible, this is not something that we would recommend officially, because of the way that we would want everyone to build applications in a single way and make it easy to switch between projects, to read Angular source code, and so on and so forth.
Yeah, because of Angular templates, from my perspective, is more powerful than just JSX, because you can handle events, you can use subscriptions, and so on. And I have questions about biggest problem of Angular developers from especially it's based on experience of my colleagues. It's a problems with subscriptions and memory leaks in Angular. Because in Angular, you need to think about unsubscribing, or think about some RxJS patterns to take until and take while and so on, patterns to unsubscribe from subscriptions. Do you have plans to do something with it for after unsubscribing and so on?
Yeah. I want to say one more thing about the previous question, but I forgot what it is. So about memory leaks, yeah, there are a few things that we have been considering. There are, for example, a few folks who there is a lot of demand for auto unsubscribe decorator that you can put on top of your observables, and on ng on destroy would automatically remove them. This is something that we're thinking about. It's not very high on our priority list, depending on if this is essential for most for most Angular developers. Then we would definitely consider implementing it. So far, there are some good workarounds from community, so that's why we haven't seriously considered implementing it in the Angular itself, in Angular core. I would, and also, although we are encouraging usage of RxJS in a lot of different patterns, like for example in the router and in reactive forms, this is not necessarily a hard requirement on using Angular. So you can use Angular without RxJS. There is a small dependency right now in Angular core, for example, on the event emitter, but not necessarily something that you must use out of the box. For debugging this, I would recommend you to use Chrome DevTools. It is usually really easy to catch memory leaks, especially if you understand the memory profiler good enough. There are excellent blog posts from community on how you can figure this out by looking at the memory profiling.
Something more about memory leaks in Angular. Andrew asked us about when will you give up zone.js? Now you have to enable on push strategy or disable zone.js at all.
Yeah, that's an excellent question. So, in fact, this is there is some research going on. Eventually, we would want to enable folks to build Angular applications without Zone.js, and over time, this may become the standard. So I cannot say for certain right now. I'm not certain in this right now. I cannot say with 100% that this is what is going to happen, but we are looking into this. There is a lot of research going on from community in particular. We're postponing this a little bit so that we can get more community input. But eventually, we would want to disable to allow Angular applications to be built without zones and allow even different scheduling strategies of change detection. So we're collaborating closely with the Google Chrome team on how we can implement scheduling of Angular change detection for different parts of the component tree with different priorities. These are really tightly related together because zoneless is going to, well, not necessarily tightly related. They're tightly related on our roadmap. Additionally, if we want to go zoneless and trigger the change detection, we would have to implement some kind of a more robust or slightly different local component state management. So these are pretty big efforts, and we will be designing them at certain points. Probably by the end of this year or early next year. But I don't expect anything coming up publicly soon. For sure, I'm pretty confident that there will be some community experiments that will be exploring the topic, and this will be also something that you would be able to adopt as well.
Do you have your favorite approach to disable zones or not, or on push strategy?
I'm usually using the default Angular stack. So one of my main goals is to dogfood the stack that most developers are using. So I'm doing experiments and research in this space, but for my Angular applications, I'm not pushing my apps in this direction.
Okay. Let's roll back to future plans of Angular because I think many are interested in it. So before I listen about you have some collaborations with different projects. For example, I forgot the name the projects that make a static generator based on Angular, like Gatsby.js, but not Gatsby. And you can make a static. Scali, yeah, static generator. And do you have plans to integrate with another interesting projects to make ecosystem of Angular bigger?
Yeah, absolutely. Yeah, if you have some project ideas for static site generators or for anything else, feel free to reach out to me directly. I would really love to consider collaboration. So yeah, definitely. Scali is doing excellent job right now. If you have an idea on approaching the problem differently, having different alternatives in the community, I think they're going to bring a lot of value. So yeah, definitely. This is not something, again, that we're going to introduce as part of the Angular CLI core. We would want to keep the framework pretty well scoped, because at certain points, taking a lot of different things on our plate would bring really a lot of maintenance costs, and it wouldn't allow us to focus on what is the on some of the important modules that we're working on, such as forms, for example. As you can see, we need to invest more in forms. So this is something that we'll be looking at in the future. We would want to keep maintaining and improving the router, the framework itself, the CLI components. So there is a lot of opportunities in community.
Do you have some concrete plans to make something better for forms, or it's just plans that you can name right now?
Yeah, forms are really high on our roadmap. We'll be sharing. Oh, actually, yeah, I think today is the version 10 release date. I need to check my calendar again, but today we will be releasing version 10, and sometime soon we're thinking of publishing officially our roadmap for the next couple of quarters. So it will be, you'll be able to see how exactly we have prioritized forms, and that's pretty much on top of our roadmap, ignoring some things like keeping up to date with RxJS and keeping up to date with TypeScript and improving our development infrastructure. We have a lot of plans for this, for sure. And there was also really great work from community that helped us to discover some of the biggest pain points in Angular forms. It was published on indepth.io by an Angular community member, describing different problems and solutions with forms. And this, I believe, it aligns with our views for forms as well.
Sorry, guys, I would like to ask one question. Hey, Minko, thanks for the great talk. So I have one question, just only one question. Are you aware of Angular Dart?
Yeah, I know that you're the person using it.
Yeah, not the one part person. There are a lot of people using Angular Dart, and like. Yeah. Maybe, I don't know. Do you use it inside Google somewhere, or just?
Yeah, it's an excellent technology. We have been working very closely with the Dart team for many years. At a certain point, we realized that this was bringing a lot of complexity on both sides, both for Angular TypeScript and for Angular Dart. So we decided to build two different frameworks instead. And this seemed to have been the right decision for now. We have been moving faster and more efficiently right now, and they are not delayed by our attempt being compatible with both frameworks. There is an Angular Dart team. There is a really large Dart team working actively on both Angular Dart, on Flutter, and the Dart language itself.
Yeah, I've heard this story because like there are a lot of things like, again, these zones, they are like inside Dart, so there is no reason to bring some zone.js to Angular Dart because they're already inbounded in Dart. And I believe that's it for now. And thank you guys for this awesome talk and QA session. And you must go to the discussion zone with a lot of people. Hope so. And that's it for today. And thank you very much.
Thank you. See you there.
Yeah, let's continue in discussion zone in Zoom.